In this video, we'll be discussing similar three-dimensional figures. A scale factor of 5/2 means that if you take any measure of the original figure and multiply that measure by 5/2, you'll get the corresponding measure of the similar figure. The similar figure then is 5/2 or 2.5 times as big as the original figure. Thus, the ratio of their measures in this case is 1 to 5/2. This ratio can be simplified by multiplying both sides of the ratio by 2, and we have 2 to 5 because the 2's cancel. So this ratio simplifies to 2 to 5. A scale factor of 1/2 means the ratio of the linear measures is 2 to 1. In other words, the new figure is half as big as the original figure. So the new figure, represented by the second number in the ratio, is half as big as the original. A scale factor of 3 means the ratio of the linear measures is 1 to 3, since the new figure is 3 times as big as the original figure. So you can think of this scale factor as 3 over 1, and so the ratio of the measures is the reciprocal of that, which is 1 to 3. Let's consider a problem. If two similar three-dimensional figures have a scale factor of 2/3, how do their linear measures compare? Well, from the discussion earlier, their linear measures will be in a ratio of 3 to 2, which is the reciprocal. Now I want to look at a couple of actual three-dimensional figures, and I'm going to use rectangular prisms just because they're easy to draw and easy to calculate surface areas and volumes and so forth. So, but it doesn't have to be a rectangular prism. It can be any kind of three-dimensional figures as long as we know that they're similar. So let's let this rectangular prism have dimensions 3, 6, and 9. And I'm doing that because I want my new figure to be 2/3 of these, and that's easy to calculate. So my new one, let me just sketch my new one here. To find the width of my new figure, I would take this original dimension and multiply it by 2/3. So I get 2 as my dimension here. The length of my new one would be 6 times 2/3, which we see is 4. And then my height of my new figure would be 9 times 2/3, which is 6. So this rectangular prism has dimensions 3 by 6 by 9, and this one has dimensions 2 by 4 by 6. So we can see then that their linear measurements will compare in a 3 to 2 ratio. which is what we said earlier by just doing the reciprocal of the scale factor. But we can see 3 to 2. We can also take 6 to 4, and that reduces to 3 to 2. And then 9 to 6 also reduces to 3 to 2. So the linear measures are in a 3 to 2 ratio. Now let's compare the surface areas of these. Let me copy the diagrams again here. We said the dimensions on this one was 3 to 6 to 9. And then on our new figure, the dimensions were 2 to 6. No, 2 to 4 to 6. Right? So for our surface areas, figure 1, if we do the front and back, we have 2 times 3 by 6, because length times width, and we have 2 of those, plus 2 times 3 times 9. That's this right and left surface, 3 by 9, plus 2 times 6 by 9. That's the top and bottom, 6 by 9. So we get a surface area for figure 1 of 198 square units. And then figure 2, we'll do the same thing. Our front and back, we have 2 of those, and they have dimensions 2 by 4, 2 by 4, plus we have 2 surfaces that measure 2 by 6. That would be the right and the left side, 2 by 6. And then we have 2 surfaces that measure 4 by 6. That would be the top and bottom, 4 by 6. This top one and then the bottom. So the total surface area for this one is 88 square units. So if we compare those, the area measures are in a ratio of 198 to 88, and that reduces to 9 to 4 ratio. Now notice that 9 and 4 are both the squares of 3 and 2. If we wanted to compare the volumes, volume of a rectangular prism, that's why I used the rectangular prism, is just length times width times height. So our volume for figure 1 will be 3 by 6 by 9, which is 162 cubic units. And for figure 2, we have 2 by 4 by 6, which is 48 cubic units. We can see that the volume measures are in a 162 to 48, or if we simplify that, we get 27 to 8 ratio. Now notice that these numbers are the cubes. 27 is 3 cubed, and 8 is 2 cubed. To generalize this, if the scale factor between the similar figures is A over B, then the ratio of the linear measures is B over A, which is the reciprocal of the scale factor. The ratio of the areas is B squared over A squared, so just the square of the linear measures. And the ratio of the volumes is B cubed over A cubed, or the cube of the linear measures. So let's use this generalization to look at this problem. If the ratio of the sides of two similar nonagonal pyramids is 3 to 4, what is the ratio of their volumes? Now, the fact that we have nonagonal pyramids makes this somewhat difficult to actually calculate volumes, plus the fact that we don't have actual side measures. But if we use this generalization about scale factor, linear measure, area measure, and volume measure, we can find the ratio of their volumes just by using this generalization. So we're told that the ratio of the sides is 3 to 4. That means we're at this point. The linear measures are in a ratio of 3 to 4. So linear is 3 to 4. That means that the areas will be in a ratio of the square of these numbers. So 9 to 16. And the volume, which is what we're looking for, will be in a ratio of 3 cubed, which is 27, to 4 cubed, which is 64. So the volume ratio will be 27 to 64, or we could write that as 27 to 64 this way.